Hello, and thank you for joining me for another video on software design patterns. So today we're going to be going over something called a Fluent Interface. So this is it's sort of a design pattern, sort of like technique for designing objects. But basically what it's for is dealing with very complicated constructors generally. I mean, that's what it's designed to fix, is very complicated constructors. Personally, I tend to use it just as a general object construction method because there are a couple benefits that I'll show you whenever we get into the code, which I will do right now. So I have some stuff written. So as you can see, we have our lovely main method here. We create one of our favorite things, which are calculators, because they're very simple to explain. And basically, we just create this and then we tell it to describe itself. So if we go into the calculator class, brace yourself, we have this. So this is a list of constructors that call each other. So if you're not familiar with it in Java, this is how you do it. So what this does is this constructor will actually call this constructor down here because it has 4 arguments. So what you may not realize, so take a moment and try to find the bug in this, because there actually is one, and I've hidden it there just to show why this is an issue. All right, if you've taken a moment, or if you've ignored that, the issue is actually right here. See how isTrig is passed in here and isProgrammable is passed in here, yet they're passed in the reverse order here. So if we go to this constructor, as you can see, isTrig and isProgrammable are passed in the same place. So basically, programmable is actually being thrown through here to trig. This is the issue with having multiple constructors like this, and why it's not a good idea, is that eventually somebody misplaces an argument, and you get all sorts of havoc. But the compiler will not warn you about this. It will not tell you that this is an issue. If you have something like Sonar installed, Sonar actually does pick this up. I actually had to turn off Sonar for this video because it was telling people about it, and I'm like, I don't want it to do that. But basically what this does is we have this calculator. It has a case color. It has a button color. So, like the color of the buttons, the color of the case, you have those, we had those grade school calculators where they were kind of blue. They had the white and the yellow buttons. Yeah, that's what that is. And then it has a list of buttons. And so the constructors tell you whether or not it's a trigonometric calculator or whether or not it's a programmable calculator. Those can both be true, by the way, at the same time. They can also both be false. If it's a trig calculator, we add the sine, cosine, and tangent functions. If it's programmable, we add the program vars, store, and recall functions. And we allow the user to optionally set the case and button color. So if I run this really quick, as you can see, we're using the default constructor, so that means that we will get a blue calculator, blue calculator, yellow buttons, not trig, not programmable, and so we'll just get the 4 basic functions: add, subtract, divide, and multiply. So if I Alt-Shift-X, J, you can see this is a blue calculator, a blue and yellow calculator. It has the following buttons, which are add, subtract, divide, and multiply. Okay. So what if we wanted to construct a trig calculator? Well, the way that we would do this with our current system is we'd pass in true there, because that will make us use this constructor, which will make it true that it has trig. And so whenever we get down to this constructor here, this isTrig will go. We'll take this branch and we'll add these 3 buttons. So if you don't believe me, we can Alt-Shift-X, J, and as you can see, we have sine, cosine, and tangent. So what's the problem with this? Well, first thing I showed you was, A, this is just an absolute mess to try to parse in your head, and 2, this does not communicate at all what we are doing. So yeah, and what's even worse is if someone decided to reverse these in the constructor, this would still compile. So basically, if they decided, hey, actually this needs to be isProgrammable, and we just decided to pass that in here, and we said, the default is false for trig. Okay, that's great, but the compiler doesn't warn us, and if we do this, we actually get a different result, so that's not good either. So we're trying to fix those 2 problems. So the first problem is, 1, this is just a mess, this sucks. And 2, the semantic meaning of this is not preserved. So the way that we do that the way that we fix that is with what's called a Fluent Interface, or one way to fix it, I should say, is with what's called a Fluent Interface. So if you've seen the builder pattern, you've seen me do this a little bit, but in this video we'll go into it in more detail. So the first thing I'm going to do is remove all of this because it is absolute nonsense. The second thing is I'm going to declare a new inner class to this. Actually, sorry, the first thing I'm going to do is I'm going to make it so that we cannot construct a calculator anymore outside of this class. So I'm just going to change this to be a private constructor. And in this case, it'll start complaining to us. It'll say, hey, I can't do that anymore. That's actually good. We'll fix that in a little bit. So I'm going to declare an inner class. I'm going to say public class, or public static class builder. If you're not familiar, in Java, basically this just means that I can create an instance of builder without having to create an instance of calculator. That's what the static keyword does here. Otherwise, if I do this, what will have to happen is before I can create an instance of builder, I'd have to create an instance of calculator, and I don't want that. I want to be able to create them independently of each other. So the reason that we want to, you can put this on an external class, but the reason that we want to do it here is just so that we can have the constructor be private and force people to go through the builder. It's another thing I like to do. And so basically what we're going to do is we're also going to create a copy of all of these variables to put here internally. And now that we have our builder, we're going to say public builder, and we're going to allow, basically this is the 0args constructor for our calculator. Basically what we're doing is we're taking this logic, we're taking this nonsense and moving it into an object of its own. And so what we're going to do is we're going to set all the default values. So we're going to say, case color in here is, I think we said blue, and the buttons were yellow. Seems like an awful looking calculator, but I don't know. So we're going to say the button color is yellow, and then buttons is already a new array list, so that's fine. We might as well, what we can actually do is we can just move these up here. That's probably easier. And then we don't need the constructor. So with a Fluent interface, what I usually do, and a lot of this is just my sort of opinion and what I've seen, but what you usually do is you have a public thing that returns the builder, and you'll say with, and then the variable name. So you'll say with case color. So you say string color, and you say this dot case color equals case color, equals color, and then you return the builder itself. And so this lets you do a pipelining kind of thing, which you'll see what that means in a bit. But let's create the actual build method. And so the build is actually going to return a calculator. I'm going to say build. So what we're going to do is we're going to return a new calculator. And we're going to add all of these arguments. So case color, button color, and then actually instead of buttons we're going to say protected boolean is trig, and that's going to be, well, that defaults to false anyway. We're going to say protected boolean is programmable. Okay, that will default to false, and so we're going to say is trig, is programmable, is programmable. Yep. And so we're going to say for the button color, we're going to say with button color, with button color, this dot button color equals color, and then we're going to say public builder with trig functions, and we could pass in a boolean there, but I'm not going to worry about it. I think it actually seems better without it, or it will read better without it. It probably won't be functional, or probably won't be, the functionality probably won't be better, but we'll just set that flag to be true. And then same thing true here with programming functions. And say this dot is programmable. So yeah, we'll have programming functions like that. And so yeah, that's how we pass all that in. And we get to keep most of this logic. So here, if you're wondering how we actually use this, what we say is calculator equals new builder, new calculator, calculator dot builder. And we're going to say dot width, case color, and we're going to say maybe it's silver. We're going to say with button color. I don't know, maybe it has silver case with black buttons. And we're going to say, I don't know, with trig functions. And then we're going to say dot build, right? And then maybe, I don't know, we'll say this is our trig calculator. And then we'll have our default calculator be up here. Because remember, the builder stores default values. Say new builder dot build. No, not build. Yes. Okay. So now we can say calculator dot describe, and we can say, you know, trig calculator dot describe. Describe the trig calculator first. Okay. So if I alt J, so what you can see is this is a silver and black calculator. It has the following buttons, has trig buttons, and then this is a blue and yellow calculator. It has the default buttons. And so as you can see, we can use this builder here to create this calculator in a much nicer way. And now if we move things around in the constructor here, we do have an issue where we have to move them around here in the builder, but it's only one other place. And so it's far less likely to cause issues. And here, that like moving those things around doesn't affect anything because we say exactly what we mean, so the semantic meaning is preserved. So you get two benefits. One, well actually three. You don't have the craziness with the constructors. You also get default values, so you can basically set the defaults here, which is something that Java doesn't really allow. You don't really have any defaulting for constructors, but if you use a builder pattern, or if you use a Fluent Interface pattern like this, you do. And also the semantic meaning is preserved, and it happens regardless of order too. So we could say, you know, want to build it with trig functions. In fact, we can actually say, you know, calc1, calc1, and say maybe calc2, and then we can say var builder. And so what we can actually do, that's actually really cool, is we can move this here, and let's say we just want a blue and yellow calculator with trig functions. We create the builder, and we just say, hey, add the trig, just have trig functions. And here we can say builder.build, and then for our calc2, we can actually say builder. We can have this builder here. We can reuse the builder, basically, is what I'm trying to say. So now note that calc2 is a trig calculator because it came from up here, you know, because the trig has already been set, like the trig variable has already been set here. And we just used this builder to build, you know, calc1, and then we use the same builder that has the same settings for calc1, but we make it silver and black. And then, you know, you could have calc3 that is, you know, white and, I don't know, red. What are other colors? I don't know, red. We'll say green and red. It's a Christmas-themed calculator, I guess. Calc3, describe. And so what you'll see is that they all basically have trig functions, but they are different colors. So as you can see, we have blue and yellow with trig functions, silver and black with trig functions, and green and red with trig functions. And if we look at all of these, they're all going to be different. I mean, you can see, since we called build multiple times, you actually get multiple copies, or you get multiple calculators. But another thing you can do with this that's really cool is you can actually use it as like a copy constructor. Well, not as a copy constructor, but you can use it to create copies of an object. So if I wanted to create, say, multiple silver and black calculators, we can obviously call builder.build, and this is calc1. I don't know why it doesn't like that. Actually, why doesn't it like that? Builder.build, it's undefined for type calculator. Ah, because we are calling build here. Yes. So if we say calc1 and say calc2, if you don't believe me, these are going to be the same. can clear this, we can remove that. We can Alt-Shift-X and then J. And what you see is that we have two silver and black calculators with just 4 functions. But if we do system.out.println, if we do calc1 equal to calc2, what you will find is that they are actually not equal to each other. So they're the same, basically they have the same settings. You basically called the constructor twice, created, 2 copies of the same object, or objects, 2 copies with the same settings, but as you can see, they're not equivalent. And I mean, for those who really don't believe me, you can call .equals and it just does not matter. Because the settings for these should not be the same. Yeah, as you can see, they're not equal. So yeah, that's one of the patterns you can use to fix, your constructors that are all crazy and nasty. And like constructor overloading is never works out well. And also having more than one constructor generally never works out well. But with this, you can also add arguments to this constructor, and the complexity is hidden right here. The clients that are constructing this object won't know. Another really crazy thing you can do with this is, since interfaces can hold classes, interfaces can have internal classes, one thing you could do is you could have this calculator actually be an interface, and then you could have a builder, and inside of the builder you could actually have a private implementation of calculator. That way clients can't see it, but also it implements calculator. So it's not something that anyone can ever see, but if you need to override it somewhere or inherit from it, you know where it is and you can do that. And so that's another really neat thing you can do with it. But anyway, I hope that explains the Fluent Interface design pattern to you, and I hope you use it in your own code because it's a really useful thing to do. Basically, if you know that an object is going to go through a lot of changes over time, or over the lifetime of the code base, it's generally good to encapsulate the construction logic behind a Fluent interface. But anyway, yeah, I hope that helps. Thank you guys for watching, and join me again in the next one. See ya.